This is an introduction to object-oriented programming in classes using C++. To this point, we've been using a technique called sequential programming. In this programming technique, the process that is carried out by the computer program follows a step-by-step procedure. We start perhaps by declaring variables, inputting the data, displaying the data, performing calculations, displaying data again, everything from a start to finish in a straight line fashion. The programmer using this technique thinks of the program as a sequence of tasks that need to be accomplished. There are advantages to sequential programming. The first advantage is it is a simple concept. It's not hard to understand. The next advantage is it is often the quickest method to solve simple problems. So if your programming tasks are to do an engineering calculation, often the quickest and simplest and the most useful method would be a sequential program. There may be some disadvantages to sequential programming. Among these, it may be necessary to repeat the code for a procedure that occurs more than once. And anytime you repeat code for the same kind of process, there is always a chance to make a mistake. It may be necessary to complete the entire program before it can be tested. That's just a bit inconvenient sometimes. A change in the code may have to be repeated in several locations. Again, the general rule is it's better to say it once and to say it correctly. If you have to make more than one change in the code, there's the probability of making a mistake increases. And the next disadvantage is that complicated programs can get very long, and it's difficult to read and understand and debug long, complicated. An alternative may be procedural programming. In this technique, the programmer thinks of the program as a collection of individual procedures and functions that can be used to accomplish the task. There may be several advantages to procedural programming. First, often used functions are not repeated. You write the function once and you make a function call to that function anytime you need to perform that operation. Procedures can be written and perfected one at a time, so you don't have to wait necessarily for the whole program to be written before you can start debugging the program. Changes in the code are easier to manage. Presumably changes would be made in one place in the code rather than perhaps in multiple places. And complicated programs are said to be easier to follow if they are written using this procedural technique. There may be some disadvantages to procedural programming. One is primary data is often stored as global data, as a global variable, so all procedures have access, or at least it's stored as a variable in the main function where a great number of procedures would have access to the data. This opens the door for accidental corruption of the data. Large and complex programs can have too many functions for the programmer to keep track of, and changes to one function may affect how another function behaves. This diagram illustrates the structure of a procedural program with global variables that are accessed by any number of functions inside the program. So there are variables in the main function, and then there will be function calls to individual subfunctions, function A and function B in this case. There are also local variables inside the function that are accessible only by that function, but the global variables can be changed by function calls to either function A or function B. If you have a large complicated program, there's a lot of possibilities for data to be accidentally or inadvertently or mistakenly changed as functions are executed. Object-oriented programming provides an alternative to this technique. In object-oriented programming, the programmer thinks of the program as a collection of objects. Objects are abstract data types. The abstract data type is a user-defined data type that combines two things. First, the data type has member data. This is the collection of data that describes the object. And the abstract data type also has member functions. These are the operations that can be performed on the data. When a program is written in the object-oriented technique, the data and the processes in the program are thought of as individual objects. An object is a programming technique that combines both data and the functions to manipulate that data into a single structure with very carefully controlled access to the data and to the functions inside the object, so that in order to retrieve or to manipulate or to somehow change the data, a message is conveyed from the program to the object, and then the object, inside the object, there are functions that can manipulate the data. So the data can only be accessed through the public interface. Public interface is designed to protect the integrity of the data. If the data is to be manipulated, a message is passed to the object instructing it to perform the task. This packaging of data and functions with restricted access is called encapsulation. Here is a diagram that shows the overall picture with an object-oriented program. The program is devised in terms of these objects. Messages are sent to the objects to interface with the data and the functions inside those objects, and information is exchanged between the objects. But the data inside each individual object is protected from inadvertent or mistaken corruption. There's other vocabulary used with object-oriented programming. The member variables are sometimes called the attributes of an object, and the member functions are sometimes called the behaviors or the methods of the object. This vocabulary changes as you go from one language to another. The public interface is designed to let the programmer access the data and manipulate the data without needing to know how the object performs these operations. This is analogous to the user interface that lets you drive your car without being fully aware of what is happening under the hood. In C++, the programmer does not start by creating an individual object. The programmer defines a class of objects. This class definition is a blueprint that describes the contents of the object. Just as a blueprint is not a house, the blueprint can be used to build a specific house, and the same blueprint can be used to build several identical houses, or the blueprint with optional features can be used to build similar but slightly different houses. When the blueprint is used to build an actual house, we are building an instance of the house. This process is called instantiation. And in this diagram, I've illustrated two classes, and the class definition describes the characteristics of the members of that class, and the individual members of that class are the objects themselves. A class is a data structure that includes data members. These are the individual pieces of information that are used to describe the class. And member functions, these are the individual functions that manipulate the data members. An object is a member of a class. It is a particular instance of one of the things defined by that class. A class may in turn be a subclass of an even broader class.